4.2, trig functions of acute angles. All right, I know why there wasn't a notes video, because there's like 3 little things, or I guess 6 technically, but so trig functions, just as a refresher, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent, I should put thetas in here, is opposite over adjacent, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. And remember the little acronym, SOHCAHTOA. Blew one of the students' minds in Algebra 2 the other day with that. They'd never seen that before. They were like, oh, that's a game changer. And I was like, how have you never seen that before? Like, you had Miss Marshall. Yeah. And then the other classmates were like, he has, he just doesn't remember it. So I was like, okay. He was like, I swear I've never seen this before. I was like, I really think you have, but okay. It was funny. I was going to say, there's a slight chance you might have seen it in Algebra 1, depending on what year it was, because my mom sometimes gets to the, like, a little bit of, like, intro to geometry, and sometimes this comes up. So I was like, there's a chance you got there, but it just depends. But I'm like, I know good and well you saw it with Miss Marshall.
I know.
So, I don't know.
I can vividly remember this on your mom's board.
I remember she would, like, when we were drawing graphs, she would use my homework as an example of how to draw it, and I always felt so special. She's like, look, she's got the arrows going out, like, on my coordinate plane.
Everything was perfect about it.
I was like, that's why I strived. Every time I did a graph, I was like, gotta make her proud.
That's awesome. All right, so these ones are actually giving you the triangle with everything already filled in. They're so nice to you. Now, I'm rarely going to draw the triangle and give you all this information, but anyways, alas, there it is. Got to start off easy. All right, so I set up all 6, usually ahead of time. Now, when I know that there's square roots involved, I try to leave a little extra space because I know that more than likely I'm going to have to rationalize somewhere in there. So I like to try to leave a little bit of space, or I just wait and draw the second column of these. But now, y'all are at the point where with rationalizing, you don't necessarily, like, if you recognize it right away, you can do that. But if you want to go ahead and write them, I like to write them the way they're supposed to be written initially, even if I'm going to have to rationalize, because then when I do the flip, I don't have to try to, like, re-rationalize it. So, because that just gets annoying. So, sine of theta, so opposite over hypotenuse, that's going to be 8 over the square root of 113. And then that one we do need to rationalize. So that's just, remember, multiplying by the square root of 113 over square root of 113, which gives us 8 square root of 113 over 113. If it's something you can reduce, you should reduce. Now, as far as taking stuff out of a radical, if it's something like the square root of 8 or something like that, where it's, like, pretty easy to take something out, that's fine. But if hypothetically something came out of the square root of 113, like, I'm not necessarily, like, if you left it, I wouldn't, you know, it's fine. Just because it makes life easier. But anyways, I would say if you get to the AP exam and there's something that could come out, make sure you take it out if it's a written out problem. If it's just multiple choice, it's probably going to be taken out, but totally up to you. Cosine adjacent over hypotenuse, so 7 over the square root of 113, which is 7 root 113 over 113. Tangent, opposite over adjacent, so 8 over 7. Now when I get to cosecant, the reason I like to write them this way initially and not go straight to the final answer is because then all I have to do is flip this. Square root of 113 over 8. Secant, square root of 113 over 7. And cotangent, 7 over 8. So pretty easy. So I'm going to move into the harder ones where you actually have to set it up yourself because, I think we're at the point where we are capable of doing that. So 10 sine of theta is equal to 2 over 3. Okay, and it wants you to find all 6 trig functions, or it says to find their remaining, but I would prefer you to just go ahead and write all 6 out over in the box just because it makes it easier to see. So I like to pretty much always draw my triangles this direction, but if you like to draw them the other way or something, totally a preference on that thing. So theta, and then I've got opposite over hypotenuse, so 2, 3 is here. So then I need to find the other side of this. So how might I do that? Pythagorean theorem. And so, again, I think y'all are advanced enough to see the modified formula of A would be equal to the square root of C squared minus B squared. Okay, so a lot of times by this point, I go straight there. With Algebra 2, I have to resist the temptation to do that, and I have to, show out every little step because otherwise they're going to be confused. So, anyways, if you want to do it the normal way, that's totally fine. But so this 3 squared is 9 minus 2 squared is 4, so that's going to be the square root of 5. So then square root of 5 goes here, and I can set up everything. So sine was given to me as 2 over 3. What would cosine be? Square root of 5 over 3. And tangent theta?
2 over square root of 5. And 2 square root of 5 over 5.
Yep. So then cosecant, flip sine, so 3 over 2. When I get to secant, okay, with this one, if you want to go ahead and rationalize it without actually writing that step, so if you wanted to go straight to the answer instead of writing 3 over the square root of 5, that's totally fine. I don't care because it's already you just know you're flipping it and you're not having to go back. But if you're worried that you're going to potentially rationalize it wrong, I would write it this way first so that if you did happen to rationalize it incorrectly, you can still get points for it. Does that make sense? So 3 root 5 over 5. And then cotangent root 5 over 2. Alright, so that one was pretty easy. They give you sine, but sometimes they aren't quite so nice, and they give it to you as secant of theta. Which, not that it's really harder, it's just slightly less nice than what they give you because it's not one of the ones that you're used to working with. So if you need to, you could actually start out with writing your trig functions over here, write secant, and then flip it to cosine to draw your triangle if you feel like you need it in one of your normal functions to deal with. But if you're like, nope, I've got it under control, I'm good with secant, that's also totally fine. So secant would be, because it's paired with cosine, it would be hypotenuse over adjacent, and so it's going to be 17 and 5 here. And then to find the other side, it's going to be the square root of 17 squared minus 25. I have no idea what 17 squared is off the top of my head.
Like 289.
Maybe. I don't know.
I'll check.
You have a calculator out already.
Yeah, but I want them to check.
They don't have a calculator out.
Maybe they should get one out. Long Virginia.
Ultimately, I just care about whatever value's inside the radical, so you can just give me that value. I swear my glasses are like so dirty. What's happening?
We all know I'm not the best with the calculator, so
Fine.
16.25. Oh, in the radical. Wait, hold on. Okay.
264.
What?
Huh?
The radical.
How did you get 16?
Oh, I took the square root already.
Oh, okay. I was like, how did you get 16?
Hold please. Square root of 264.
Okay.
Yeah,
I
oh
was-
God, I'm not the best for it.
I was so confused. I was like, well, when you said 16, I was like, well, that makes sense for that side, but where'd the square root go? So this is one where you can either leave it because it's a really big number, or we could break it down. I assume it can break down.
Like 2 root 66.
Is that what it is?
Someone else's turn.
So you can rewrite this as 2 root 66, like he said, if you want to. I don't care which way you do it. Sometimes it'll make things cancel, sometimes it doesn't, so it just depends. But mainly want you to see it because I'm pretty sure on the AP exam they're gonna make you break it down, which is technically the right way to do it, but you know. So they started us with secant, so I go ahead and write that one in. Cosine, I would just go ahead and flip that one and get that value since that one's easy. So what's the sine of theta?
2 square root 66 over 17.
Yep, so you can do that. Or if you had written it as the square root of 264 over 17, that also would be fine with me. I don't really care, so. Tangent.
2 square root 66 over 5.
Yep. So then cosecant, I'm going to bring this over because I'm probably going to need some more room. So cosecant, when we flip it, we've got 17 over 2 root 66. So then when we rationalize it, that's going to give us 17 root 66 over 2 times 66, okay, which is, what is that, 132? Okay, if at that point, if the 17 and the 132 reduce, which I don't think it does, but maybe it does, I don't know. It does not. Then you would reduce it, but if not, then you would just leave it like that. Anyways. So then cotangent would be what?
5 over square, or 2 square root 66.
And then that would rationalize to what?
5 squared 66 over. This is 132.
Let's say it's only 1 point.
I think
already done.
I have to make sure before I say anything.
All right, it looks like if we need to see another one of these tomorrow, we can, or if you feel like you've got it under control or whatever and you're good, then we won't do another one of those specifically. But tomorrow we'll basically answer questions using the unit circle. Do y'all want problems for this stuff so far, or do you just want to wait and get them all tomorrow? Okay. Tomorrow's stuff should probably be relatively fast. We'll basically just be look at the unit circle, answer the question. Like, what's the secant of pi over 3? And we'll find that. And then we'll also do a few where they give you an angle value and a side value, and they want you to find the other side that they are giving you. So you're not finding all 6, you're just finding, or like I say all six things. You're not finding all 6 angles. You're just finding whatever piece it's asking you for. So those are pretty fast. We might do one of just finding all 6 things just for a refresher to make sure that we remember how to do that. But actually, there are a couple problems where it asks us to do all 6 things, so we'll do those too, but not a lot of them. So anyways, that'll be tomorrow, and it shouldn't take us the whole time, I don't think. 4.3 Thursday. I think I might have put a quiz date up on the board, but I don't remember. I know unit circle quiz, I think Friday. So we'll basically do, and it'll be like a practice quiz. So if you do well enough, you won't have to retake it. So if you get at least 100, because remember I do it as 66 out of 64 is the best you can get. So if you get at least 64 out of 64, you don't have to take it again. And then we'll do a retake on Monday, and then probably a regular quiz on Tuesday is my thought next week. On 4.1 to 4.3, because I think there's only 6 sections in this, so I try to break it in half.